have any questions about Vandal's tutoring? Oh, yes.
What can you expect at the tutoring session? Do you just go over random projects, or will it help you with your homework? How
Yeah,
does that work?
so it's whatever it is you want to go over. So it could be like homework, it could be sample, like tutors also have sample problems for you as well. So yeah, it really is catered to whatever it is you want to focus on in the workshop. So it's not like, we don't have like lesson plans created, there isn't like prepared material. It's whatever you want to focus on during that workshop.
And you may have said this, but Sean McCormick's his tutoring session from Monday 6 to 8, is that a Zoom session?
So everything's in person.
Oh, it's in person.
Yeah. So it'll be in person. You'll be there from 3 to 8 on Mondays, and it'll work out from 6 to 8. All right, the last thing I just want to briefly share with you is this been shown pretty conclusively with the data, is that students who take advantage of tutoring on a consistent basis, or at least like once every week or once every 2 weeks, gets 1 grade higher than students who never come to tutoring at all. So that could be a difference between an A and a B. It could be a difference between a C and a D. So I strongly encourage you to take advantage of this free resource. And again, tutoring starts next week in the library, Monday, and our tutoring hours are Monday through Thursday from 2 to 8 p.m. So thank you very much, and I look forward to seeing you in the library next week. Thank you.
Thank you.
Thank you very much.
Yeah, thank you, Bill. Okay, any question about tutoring? And we had tutoring last semester for my CHEM 101 course, and you can ask students who had the course, they loved the tutor, and they had like better understanding of the concepts, and sometimes, you don't understand something in the class, and I try to be approachable and friendly, but sometimes the student is more comfortable with someone like themselves, a student, not a professor or advisor, and they were so comfortable with her, and then would go to her, ask questions, and also sometimes they would reflect what they liked or disliked about how I was teaching, and my tutor anonymously would tell me that, okay, this is like students' feedbacks, and it helped me to teach better. So I highly encourage you to attend. And last semester, I also was devoting extra credits to attend the tutoring sessions. And depending on our course needs, I may do that this semester too, to encourage you. Because if you don't go to the tutoring, you cannot compare it, you cannot see how useful it is. But when you go to the tutoring, you see how helpful that can be. So I guess depending on the course needs, I may also devote extra points. For that, I devoted like 10 points extra credits to go to tutoring. So I guess I'll see the attendance of tutoring and then how things go, and I may also devote like some extra credit to encourage you to go to see how helpful that is. Okay.
Thank you.
Thank you so much. So before I start with the next lecture, do you guys have any question about the previous lecture? So can anyone tell me what is a kernel?
All the electrons besides the valence electrons?
Yes. Can anyone else also tell me? Yes?
It's the nucleus and the extra electrons that are not in the valence shell.
Okay, yes. So is that clear? So can anyone tell me what is the number of valence electrons for silicon? You also have like the periodic. Yes? What is it? Is that clear why it's 4? Because when you look at the periodic table, so this periodic table on your classroom, it has the groups at 1, 2, 3, 4 till 18, right? But in general, there is another nomenclature that you have like the transition metals as B's and the main group elements as A's, right? So you have like 1A, 2A. So group 13 would be 3A, 14 would be 4A, and so on, right? So if there is an element in group 18, it's like basically 8A. And whatever the number of group is, you have that many valence electrons, right? So how many valence electrons lithium has? 1. Is that clear why? What about aluminum?
3.
Argon.
8.
Okay, so we should know these things really well because these are like the basis of the course. So, can anyone tell me what is a cation?
That's a positively charged.
Yes, so it's an element that lost electrons and now it's positively charged. What is an anion? Negatively charged. So, what type of chemical bonding cations and anions form? Ionic, right? And what type of, so let me paraphrase. If during a chemical bonding electrons are transferred, what type of chemical bonding we have? Ionic, right? So remember, for ionic bonding, electrons are being transferred, but for covalent bonding, electrons are shared. Is that clear? Okay, so let me go to the first picture that I have here. And as I said, after this session, I'm going to go to my office and then put everything in a PowerPoint and post it, so you don't have to worry about taking notes. But if that is your learning style, I had like some students emailing me that they like to take notes. If that is in that way you learn better, take notes. But I don't want you to not listen to me because you're worried about you're losing information. Anything that I talk in the class, you're gonna see on Canvas. So don't worry about that. So here, I wrote some definitions to save some time instead of me writing with you. So, as I mentioned, ionic bonds are formed by the transfer of electrons. And as I emphasized before, the electrons in kernel, non-valence electrons, they're not being transferred. We're only working with valence electrons. And that's why if you have like, for instance here, let me choose this color. You know, you have like sodium. How many valence electrons it has? Right? You just remember it was group 1A, 1 valence electrons. What about chlorine? 7. And do you all remember how to write Lewis structures for each of these? So you write chlorine, and then you put 7 dots here. You know, 1, 2, 3, 4, 5, 6, 7. And usually you have like that, you know, this lone electron, or like, you know, the one that is not paired, you put that where you want to form a bond so you can pair them. And that is more applicable for covalent bonding because this is how we show them. But in general, for instance here, you know, you have like chlorine here and then sodium here, so you have them next to each other so you can depict the transfer of electrons. So do you remember that if we have like, you know, so we have like group 1A, 2A, you know, we have our metals, we have our non-metals. What electron configuration in general atoms want to reach? For instance, if we have like lithium, if lithium wants to form a chemical bond, what is the tendency? How many valence electrons eventually it wants to have? Yeah.
Be an octet?
Yes, octet. Does anyone remember what was octet? Yes, so octet, it comes from it's kind of like octane, or like, what are some other words with? Octopus, yes. Yeah, that's a great example. Yeah, it means 8, you know, so anything that has 8, you know, that was brilliant. So you guys probably know words, you know, way better than me. But you remember, so they want to have 8 electrons in their valence shell. And do you remember which group of elements they have 8 electrons in their valence shell? Noble gases. And you know they're not reactive, right? They don't want to participate in any reactions because they have 8 electrons in their valence shell. They are all set. But the other elements, they want to lose or gain or share electrons, so they have like 8 electrons in their valence shell. So they want to reach an octet. And we have like some exceptions like hydrogen, helium already has 2 electrons, not 8. And lithium also wants to lose 1 electron to reach and do it. So basically having 2 electrons. But in general, most elements, other than these, they want to reach an octet. So here we mentioned, so what is a cation? Exactly, an atom that is positively, now I messed up this chlorine charge, but you see that here, so don't worry about it. What is an anion? An atom, yes, that is negatively charged. Okay, so here when sodium loses 1 electron, it becomes like Na plus, and then Cl, when it becomes an octet, it becomes Cl minus. And you remember from like previous chemistry basic course that we call anions, we add like the base name of the non-metal plus IDE, so we name that chloride anion or like chloride ion, but the non-metals we just add a cation, so we call it sodium cation. The name doesn't change. Is that crystal clear to everyone? Okay, so let me go to the next thing I have here. So now I'm going to talk about electropositive and electronegative. Does anyone know what is or what are electropositive atoms? Anyone? Do you know what is an electronegative or electronegativity in general? Yes?
Electronegativity is when it wants to pull the electrons closer to itself.
Yes. So it's the tendency of absorb electrons, right? So, and then electropositivity is the opposite. So here, so electronegative atoms accept electrons and form anions, and then electropositive atoms give up electrons and form cations. So with that definition, what is lithium? Is it electropositive or electronegative? Electropositive. Most metals, they want to lose electrons, right? And most non-metals, not all, most of them want to gain electrons. That's why we don't have like F plus, right? Because fluorine wants to gain electron, not lose electron. Does that make sense? Any question about that? As I said, these are like basic concepts, but if you don't learn these, the rest of the book would be really difficult or impossible to learn. So just, interrupt me, ask me if you have any questions. So now, let me go back to, or like, not go back, but let me show you periodic table. And your book, when you read the chapter, as I asked you to, you see like the different ways that the book try to teach these concepts, or like electropositive, electronegative atoms, and then comparing them. I think the best way is to remember when the metallic character is more, electropositivity is more, because metals want to lose electrons. So if there is metallic character is more, electrons have more tendency to lose electrons. The same thing with electronegativity. The non-metals, or like when the metallic character decreases and elements become more non-metal, they want to, gain electrons. So electronegativity increases. Does that make sense? So with that definition, and this is how I was teaching last semester for my CHEM101 course, and I thought it was like useful. So if you think of it this way, if I ask you, when we go in periodic table, and you guys remember row and columns in periodic table, right? So so tell me this element, platinum, what row and what column platinum is in periodic table. First, let's say what column. Yes, or if we work with the AB system, what?
AB.
Yes, so this is like the column number, right? Is that clear? So what about the row? What row platinum is in? 6. And then so if you can just start counting from here. 1, 2, 3, 4, 5, 6. And also you see the number here. So this is row or period. And then 10 or 8b is like column or group number. Okay. So if I tell you in the periodic table, when we go from left to right in a row, metallic character increases or decreases?
Decreases.
Metallic character decreases. And I was telling the students, and I'm telling you now as a review, that here, look at here, except like, just forget about hydrogen, except that here you have like alkali metals. Here you have like alkaline earth, group 1A, and 2A, remember here. And then you go here, you here reach metalloids. Do you remember metalloids that they had like some characteristics of metals, some characteristics of non-metals, they were in between, right? And here you have totally, completely non-metals. So if you just remember that, you realize, okay, she said left to right, I had like alkali metals, alkaline earth, and then I had like metalloids and non-metals. So metallic character decreases, right? And then the same thing with the groups. If I ask you here, in this group, metallic character decreases or increases, or like here, maybe it would be hard to compare because we just see like radium, magnesium, calcium, unless we go to a laboratory, do some experiments, or like read the literature. It's just difficult to just look at these and then talk about the metallic trend. But here, if I go in this group, you see that, okay, nitrogen, phosphorus, we have like non-metals, then we have metalloids, then we have metals. So in one group, when I go up to down, metallic character increases or decreases? Increases, right? So when you consider this part, you can just talk about the periodic table itself. Is that clear? And I'm going to ask you in your homework assignment for like that would be due next Wednesday. And now I remember to remind you about like the first homework assignment that is due tonight. And so this is how homework assignments work. After Friday, each Friday that I finish the lecture, I go back to my notes, anything that I taught to the videos, and then the PowerPoints that I posted for each lecture that I'm teaching, anything that I talked in the class till Friday. I wrote the homework assignment and posted. So for instance, for this homework assignment due tonight, anything that I talked today won't be on this homework assignment. Does that make sense? And I wanted to have the deadline on Monday before the Monday class because I wanted the students to accomplish that. But I thought maybe some students don't prefer to have deadlines after weekend, so I have the deadline till Wednesday. But I encourage you to study the course during the weekend, and then just before the next class, you do the homework assignment so that you know the materials before the next lecture. Anyway, so I'm going to ask you several questions about this. Which one is more electropositive? So is it silicon or chlorine? You can just like look at the periodic table or like here on the board. So silicon or chlorine, which one has more metallic character? Silicon, right? Or magnesium or calcium? Magnesium or calcium, which one has more metallic character? Yes. Or I say, which one is more electronegative, magnesium or calcium? Right? So in general, metals are like electropositive, but I also can ask you which one, it's kind of like, I say which one is more non-metal, magnesium or calcium. There are metals, but it's still the one that has less metallic character is more non-metal. Does that make sense? Any question about this? Okay, so let me go back to electropositive, electronegative, and that. So now, that being said, can anyone tell me that, so first of all, what charge beryllium atom carries if it wants to, so beryllium as itself, it doesn't have any charge. But if it wants to form an ionic bond, what would be its charge when it becomes a cation? Plus 2. Is that clear why? Because beryllium, one way is that to write the electron configuration that you learned last session and from previously, right? Or write Lewis structure and see how many electrons beryllium is lacking to become an octet. The other way is just look at the periodic table and say beryllium is in group 2A, so it has 2 valence electrons, so it wants to lose those 2 valence electrons when it forms an ionic bond. Is that clear? So what charge sodium carries if it forms an ion? What about aluminum? So why not -3? Yes?
Because it's on this side of the metalloid line.
Okay. So we have like metalloids in group 3A as well, but aluminum is a metal, right? So why aluminum, gains charge of +3 but not -3? Yes?
Is it easier to give up 3 electrons than gain 5 electrons?
Yes. Does that make sense? So as I said, elements want to reach an octet. And then we should see which one is easier. For instance, lithium, or like, let me go to sodium. So it's easier to lose just 1 electron than gain 7 electrons. Or like, as your friend mentioned, like for aluminum, it's easier to just like lose 3 electrons. Does that make sense?
So it's a plus 3. Yeah.
Any question? Yes.
So for like group 4A,
Uh-huh.
could it go either way?
Yes, and that is a really good question, and the thing that I'm going to teach you today, and especially we focus on carbon, because the course is carbon compounds. For group 4A, and specifically carbon, they can lose 4 electrons or gain 4 electrons. So first of all, they don't form ionic bonds. Carbon forms covalent bond. And depending on what structure we have, it may lose or gain 4 electrons. And this is kind of one of the main objectives of this book, to talk about carbon and carbon compounds. So that's why these are like introduction. I should like teach chapter 1 in 2 sessions, or just like skip it and then say it's review. But these are like fundamentals. So I want to emphasize, and I apologize if these are like repetitive for some of you, but I just want to make sure everyone knows these things well. Any questions so far about anything? Okay, let's do, yes.
So for the metallic character, if you're going period-wise, it decreases, but if you're going columns, then it increases?
Yes, exactly.
That's the normal rule?
Exactly, and you always remember the groups that you have metalloids, You have like nitrogen, phosphorus, that they are like non-metals, and then here you have like arsenic, antimony, that they are metalloids, and here you have bismuth that is completely metal, or here, boron, aluminum, or like carbon, silicon, and so on and so forth. So metallic character increases when we go up to down in a column.
And that still applies even if you're all the way over in like 2?
Yes,
Okay.
exactly. Yeah.
Okay.
Yeah, I couldn't see this part well on the palette, but you get the idea. Okay, so let me go back and see if I covered everything I wanted here. Okay, which atom is more electropositive, lithium or beryllium? Which one?
Lithium.
Which one?
Lithium.
Why?
It's farther to the left. Electronegativity increases as you move to the right.
So
So electropositivity increases as you move to the left.
So let me ask you this. When we go left to the right, metallic character increases or decreases? So why decrease or increase? So left to right, look at your periodic table. You have like, for instance, if you look at the third period, you have like sodium, magnesium, aluminum, and then you have chlorine, which is nonmetal, and argon, that is nonmetal. So left to right in periodic table, metallic character increases or decreases? Decreases, right? Because you have metals, and then on the right you have like noble gases, really non-metal, right? So if metallic character decreases, electronegativity, does it increase or decrease? Increase, right? I mean, noble gases, I guess, should be excluded from this argument because they don't want to lose or gain electrons. But in general, non-metals want to gain electrons, so they are like more electronegative. What about electropositivity? So let me ask you this. Compare sodium to chlorine. Which one wants to lose electrons? Sodium. So electropositivity left to right increases or decreases? Right. So with that rationale, which atom is more electropositive, lithium or beryllium? Lithium. Is that clear? Any question? And again, if you just confuse this, because these are two non-metals, it's hard to compare. You can just compare lithium with like fluorine in the same row, and then say, okay, which one wants to lose electrons? Lithium. Right? So let me check our answer. Yeah. So example 1.3. I mean, I was like doubting myself. I'm gonna tell you something wrong. So lithium is the more electropositive atom with the rationale that we said, right? So what about lithium or sodium? So in one group, up to down, look at lithium, sodium, potassium, rubidium, cesium, francium. In one group, when we go up to down, metallic character increases, right? So what about electropositivity? Also increases, right? So lithium or sodium, which one is more electropositive? Sodium. And then sodium is the more electropositive element between lithium and sodium. Any question about this? Is that clear? As I said, I'm going to give you so many homework problems and also in your exam too, but if you just learn this, the metallic character and how it relates to electropositivity, electronegativity, I think that would be good. Okay, to give you guys a break and also something that I was thinking about the attendance, I was thinking of different websites and I realized SurveyMonkey is like the most user-friendly one. So can you all go to this link right now and then answer the 2 questions? And let me know if you have any difficulty. So you should see 2 questions. One of them is talking about like the definition of cation, anion, just one question. And the other one asks for your name that I only can see. And you don't have to worry about the answer to the question. It's just kind of like I want to see how many people got the thing that I talked about right, and I don't see who answered what. I just want to have an idea how many people answered correctly or incorrectly, and then I want to see your names. So I thought this is like more efficient way to do this. And if anyone had like technical difficulty logging and entering their names, just come to me after the class, tell me your name that you attended the class.
Wait, I have a question.
Yes?
Did you define metallic character?
So metallic character is basically it's really, it's kind of like the hen and egg situation. It's kind of like, the metallic character is the ability of the elements to lose electrons. And when they lose, if they can lose more electrons, or this affinity, or like this tendency to lose electrons is more, we say that they have like more metallic character. And nonmetals, this, affinity or like this tendency to lose electrons is less. So the definition is kind of like really, related. And there are like some characteristics that metals have that defines the metallic character as well. So like, conducting electricity or heat, or like kind of like, something in Farsi we would call like chakoshkari. I'm just trying to think of the English word. But the tendency of like, we can change their shape without being broken, it's kind of like different. But the closest official definition relates to the tendency to lose electrons.
So it's easier to lose electrons when you have just one?
So
I'm just confused about if Li is, lithium is a charge of +1 and beryllium is a +2. Like, why is it that lithium can give up more easily than beryllium?
it's because of if you look at their electronic structure, so for instance, if you have like, nucleus that has like positive charge, and then here in the first shell, you have like, so lithium in general has like 3 electrons, so it has like, 2 electrons here, and then 1 electron here, right? So this is for lithium. And then for I guess I just show it like here, and these would be like roughly the same. I'm trying to depict the same thing. So here for beryllium, we have like 4 electrons in general, right? E, right? So this goes back to the interactions between nucleus electrons themselves, and so interactions in nucleus, so in positive interactions, and also electrons and nucleus, so negative positive interactions, and also negative interactions between like electrons. So here, because of all those interactions and quantum mechanical interactions that are like exist between like these 3 components, these three terms, basically, this electron is easier to leave lithium than this electron here. You can think of it that way because of these for beryllium, it's kind of like balanced between electrons and nucleus. So this one that is like 1 electron there is easier for lithium to lose it. And the other thing, is ionization energy that defines metallic character, which is basically the tendency, the energy required for an element, that the energy that we should give to an element to lose 1 electron. And that energy specifically defines metallic character. So if ionization energy is more, metallic character decreases, so we have like more nonmetal. Imagine like fluorine or like chlorine, they have like 7 electrons in their valence shell. And then if we want to force it to lose one of them, it's really difficult for fluorine, but it's easier for it to gain 1 electron.
That makes more sense.
Okay, so everyone did the attendance? We are all good? Okay, so now going back to the lecture. Talked about this, that. Okay, now let's talk about covalent bond. And we talked briefly previously for ionic bonds. So if electrons being transferred completely, we have ionic bonds, right? And for ionic compounds, we don't have the traditional bonding between 2 atoms. So when you have like sodium and chlorine atoms in sodium chloride or table salt, we don't have like, they're not bonding with each other in a sense that they share electrons or anything, right? So we have like a sodium ion that is surrounded by chloride ions, and depending on what crystalline structure the salt has, the number of atoms that surrounds that specific ion differs. But for covalent bonds, the electrons are being shared between the atoms. And depending on how many electrons are being shared, we have like different types of bonds. If we have like only 2 electrons or 1 pair electrons, it would be single bond. If we have like 2 pairs of electrons or 4 single electrons, it would be like double bond and so on. And if we have an element that is strongly electropositive, they lose electrons. Or if an element is strongly electronegative, they gain electrons. But there are like some elements that they are not strongly electronegative or electropositive. So what they do, they share electrons. So just what I said here, the elements that neither strongly electronegative or electropositive, or they have similar electronegativities, tend to form bonds by sharing paired electrons. And remember, when we say sharing electrons, we talk about covalent bonds. When we talk about losing or gaining electrons or transferring electrons, we talk about ionic bonds. And something that I advise all of you to do, both for my course and for all your courses and in life in general, if you have a multiple choice question, read all the answers. Even if you're certain that you know the answer. I had several students last semester, they would go out of the test thinking that they are getting an A. And then they would get a C or even fail the test because most of the questions, I was saying which of the following is not a covalent bond or like is not. And then they would answer, they would see like methane and they would choose that because they didn't see, that I asked which one is not included or whatever. Does that make sense? So read, and sometimes I have like 3 correct answers and I say all of the above, and then you see the first correct answer. So just read all the answers, even if you're 100% sure that is the answer. Does that make sense? Okay, so what is a covalent bond? Now I talked so much. Can anyone tell me what is a covalent bond?
The sharing of electrons between 2 atoms.
Yes. Is that clear? Are you guys getting bored or like waiting for the class to finish? What's going on? Are we doing good? So how many of you are learning things and so let me ask you, how many of you guys knew already all these materials? Okay, how many of you find this useful regardless? Okay, cool. Okay, sometimes I just feel I'm boring students with just like talking about things they already know. Anyway, so a covalent bond involves the mutual sharing of 1 or more electron pairs between the atoms. And what is a molecule? Can anyone tell me? You can also look at the board, I don't mind. I just want class participation so you don't hear my voice, like 100% of the time, So you hear some better voices too. Anyone? Yes? You want to answer? No? What is a molecule? Yes?
It's gonna be multiple atoms that are joined together.
Okay. Yes? Exactly, right? So 2 or more atoms joined by covalent bonds constitute a molecule. So if I tell you, is the following statement true or false? NaCl is a molecule.
True.
Why? Okay, I heard ionic bond, sodium. Okay, yes?
It's joined by ionic bonds, not a covalent bond.
Yes. And if you look at like sodium chloride, let me do this now. It was supposed to, okay, had delay. So now for the people that are watching the lecture at home, I'm referring to figure 1.1 in the book that shows like sodium chloride. You see sodium chloride, NaCl, is an ionic crystal. The purple spheres represent sodium ions, Na+. And the green spheres are chloride ions, Cl-. Each ion is surrounded by 6 oppositely charged ions except for those ions that are at the surface of the crystal. So they don't form, so they have like chemical bonding, they have ionic bonds, but they're not a molecule. You see the difference? For the molecules, they join, with each other. Let me see, here we have like this, like Lewis structure, that they are like form bonds. Actually, carbon and carbon, I guess you can say touch each other, I don't know what is it. So you can think of them that they form actual bond. So for covalent bonds, sodium, carbon or hydrogen, they actually form a bond that we, depict with a dash between them. Or like kind of like this molecule at your book, you see, they have bonds in between them. But in ionic bonds, sodium and chloride actually don't share electrons. So you don't see that dash depicted between them. They are just surrounded by ions. So if you have like sodium ion, does that make sense what I'm saying? Okay, let me go back here to the HDMI. Okay. So, and let me go back or like go to this slide. So this now we start to actually, start our course. The previous things that I talked about, they were kind of like review, and you had to know those things for learning about carbon and carbon compounds. So as we briefly mentioned previously, and your friends brought it up, when we have like carbon is in the middle of the periodic table. So it's not as strongly electropositive, it's not as strongly electronegative. And for that matter, carbon forms a covalent bond. So it shares electron. So can you guys try to write the Lewis structure for methane, CH4? So you try to do that while I'm writing it here. So do you guys remember how we would start? So you write carbon, and how many valence electrons carbon has?
4.
Exactly. And then you put 4 dots, 2, 3, 4. And we start, kind of like, Hans' rule, that we first fill them singly, like orbital diagrams. So put 1 on each side and then pair them if we have like more than, one on each side. So if we had like, one more, we first have 4 on each side. Does that make sense? And then for hydrogen, how many valence electrons hydrogen has? 1. It has just 1 electron, and that is like, and then we have like CH4, so we put 1 here, 1 here, 1 here, right? And then these two, you can depict them by a dash. So in general, you can write CH4 as this, right? So what about, is that clear how we did this?
Yeah.
So let's do for carbon tetrachloride really quick before the class ends. So we put carbon here, 1, 2, 3, 4, right? And then for Cl, you have like 7 valence electrons because it's in group 7A or 17, right? So you put like 1, 2, 3, 4, 5, 6, and as I said, put the one that is alone next to the atom that you want to form a chemical bond. So here, 1, 2, 3, 4, 5, 6, 7. And then the same thing here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then these ones, you can form a chemical bond. So in general, you can write it as, that is C. Cl, 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 and then 2 here. And then here I have technical, oh, I guess I can just like, okay, do this. And then 2 here, right? So if I ask you now in this structure for this chlorine atom, that one, how many electrons it has now? 8, right? Because you say, okay, 2, 4, 6, 8. So now both atoms, chlorine and carbon, are sharing electrons. Okay, everyone, I don't keep you more than this. Just finish homework assignment 1 and email me if you have any questions.